Hello and welcome to the OneMedicine Podcast from today's practitioner. In each episode, we share the expertise of a respected thought leader. Some you'll know and others you'll probably meet for the first time. We cover topics important to you, always with a focus on improving the health outcomes of the patients you treat while expanding your understanding of the many healing modalities being used today. Hi, and welcome to the OneMedicine Podcast. I'm Rob Lutz, your host, and with me today is Matt Lim. Matt is a clinical educator with CellLogic, and we're going to dive into nutrigenomics and some specifics around ways that we can influence that, particularly around oxidative stress. Matt is an integrative dietitian who has always been fascinated by the power of food to promote health, nourish the body, and tantalize the taste buds. While studying biochemistry, Matt became enamored with the potential of phytochemicals to improve health and wellness, and remains especially fascinated by the medicinal properties of various culinary herbs and spices. With degrees in biochemistry, nutrition, and dietetics, Matt's broad educational background and clinical experience in sports nutrition, weight loss, and diabetes enables him to translate complex science into clinical solutions. So as we talk today, Matt, our audience are medical professionals. And so I'm really looking forward to understanding a little bit more about nutrigenomics, how practitioners can leverage that in their practice to improve health outcomes.
Yeah, I'm excited to be here, Rob. Thanks very much for having me. And I think, the theory and the science is one thing, but ultimately clinicians are after a solution to their patients' needs. And so where the rubber meets the road is, very important. So I hope I can share some of my insights with your listeners today.
That's great. So why don't we start off right kind of at the very basic level? What is nutrigenomics? How would you describe that or define that for us?
Yeah, so essentially it's the interaction between your body's genome and food molecules, including some nutrients.
Mm-hmm.
So it's really a fundamental interaction between the body and its environment, specifically relating to food molecules. So, in the past, we thought that genes, first of all, we discovered that there were genes, but after that, we thought the genes were static. They were just there. Now we know through the advent of, advances in molecular biology and mapping the human genome, that they're really dynamic. So you can modify their activity, you can block their activity, or you can promote their activity. So it's a fascinating science that, like I said, looks at the interaction between your genes and your diet, and specifically what we call these signaling molecules. So I'm sure we'll get into that a little bit more, but it's great. And it's enabling practitioners to be much more targeted, particularly with the genetic testing and so on. I hope that answers your question. I probably waffled on a little bit.
No, it does. So I think maybe I'll just try to repeat it back a little bit. We're all born with our genes, right? But it's not necessarily that doesn't tell the whole story. You can really influence that with the foods that you eat to some extent.
Yeah. There are certain genetic pathways that I, in particular, and many other clinicians have focused upon, and they're definitely influenced by the way you live your life, not just diet, but exercise regimen, how you sleep, how you think as well. It's fascinating, and it gives us an opportunity to influence our body's cellular function at a very, very basic level. So healthy gene expression is what we're after, which creates healthy cells, tissues, organ systems, and your whole body.
Can you talk a little bit about some of the nutrigenomic mechanisms? Go in a little more detail about that. How does that work?
Well, essentially, when you take in certain food molecules, they activate certain pathways. I mean, one that we focus on at CellLogic is called NRF2. NRF2 is a transcription factor. So simplistically, we say, well, it's a genetic pathway, which it is after you activate it. And it's a molecule that is in the cytoplasm of the cell. And when it's activated, it goes into the nucleus where it attaches to a number of genes. In the case of NRF2, there are 2,000 target genes, 2,000 approximately target genes. So when that pathway is activated, 2,000 genes are turned on and turned up. So genes make enzymes, and so all of the products of that genetic expression, enzymes which in your body cells and in your body are catalysts for chemical reactions. And essentially we're just a very well orchestrated bag of chemical reactions. That's a very basic look at one of those pathways. And it's something we can activate really powerfully with your lifestyle and certain things from the diet.
So, specifically, what are those pathways what are they influencing in someone's health and wellness, would you say?
Yeah, well, you mentioned oxidative stress. The pathway actually is activated by oxidative stress in the cell. So in your cell, you've got a balance of oxidative stress. It's called a redox balance, reduction oxidation balance. And so it's like wanting to have, I'm not familiar very much with Goldilocks, but you want to have just the right bed, right? Not too hard, not too soft, just right. I hope I haven't mixed it up with the Three Bears or something, but I think I haven't. So the cell likes to have a nice, happy middle ground, okay? It's like temperature. You exist, and your pH and pressure of gases in the blood, it likes to be in the middle happy zone. What happens when you shift out of that happy zone? That is, there's more oxidative stress in the cell. NRF2 is activated. One of the genes, and there's many genes that are turned on by this process, codes for superoxide dismutase.
Mm-hmm.
So SOD is really one of our major antioxidant enzymes. So when NRF2 is activated, SOD is produced. It then starts to quench these free radicals, which brings down oxidative stress, and then that NRF2 pathway can turn off.
Mm-hmm.
So it's kind of like a thermostat. You set the temperature, and that's the set point in the body, the set point for oxidative stress. When it's out of that zone, when it reaches a temperature, it turns off. And so it's always on and off. Oxidative stress is in a constant state of flux. So your body's adapting to its internal and external environment, really in quite an intricate fashion to maintain optimal levels of oxidative stress and therefore cellular function.
That's great. And so, yeah, I think I mentioned to you before we started the podcast that I had gone through the 3X4 testing. And one of the areas that they looked at was, how well do I manage oxidative stress? And apparently that's an area that I have some challenges with. So they made recommendations: prioritize plant foods rich in antioxidant nutrients, avoid pollutants, help neutralize damage caused by harmful byproducts from normal biological functions. Oxidative stress contributes to premature aging and several other diseases. So, that was something that was, as we looked through my personal genetics, that was something they identified that is, I'm challenged in that area. And it was interesting. Before I knew you guys, they actually recommended your product with sulforaphane to help with that. So I've been taking it, but I'm just curious. So folks like myself that have some oxidative stress challenges, but everybody's bombarded with oxidative stress every day, right? With things that they eat, their experiences, right? Can you talk a little bit about that? And, what's the...
I mean, we live in an unnatural environment now. Of course, if you're concerned about your health and your family's health, you try and do those things that minimize those stresses. So I say stresses as in ES and stressors. So, we have a number of stressors that impact your body's function generally and your cellular health. If you are impacted by this, a single nucleotide polymorphism, your test shows that, then you've got to take extra steps in order to ameliorate those effects. So one of the ways is by activating NRF2, which, as you mentioned, can be achieved by utilizing something called sulforaphane. So for those who don't know, and there's a lot that will know, sulforaphane is a molecule that you can obtain when you eat some cruciferous vegetables, but not all cruciferous vegetables will yield much sulforaphane. So broccoli is the best plant, and indeed the broccoli sprout is the most concentrated way to obtain it. That's one way, through these specific molecules. But there's lots of other things you can do with your diet. I should mention that it's not only oxidative stress inside your body's cells, it's also oxidative stress inside the gut, lumen, right? That's important to try and manage. So you have a tube that goes through your body, the gastrointestinal tract. That's basically the outside of the body. And it's quite a hostile place. I mean, you would not want to go through your own gut. And that sounds ridiculous, but first of all, you're getting chewed up, then into the stomach where the pH is very low, very acidic, and then you go into the small intestine and your body releases all these things to increase the pH. So you got all these pH changes, which is enough and violent enough to break down all but the very toughest food products. And then you go into the bowel where there's a lot of bacteria, pH changes again, and there's all sorts of stuff going on. I see your report here, Rob, and it mentions things like polyphenols. It's a really interesting thing. I think we should spend a few minutes on that. So polyphenols are antioxidants. But polyphenols are typically not very well absorbed at all. But because of that, they're fantastic antioxidants inside the gut, which, as I mentioned, is something, well, a place where it's vital you try and reduce oxidative stress. They're a fantastic prebiotic molecule, so they feed gut bacteria. But they're not like prebiotic fibers, which in some people who have inflamed guts can cause problems and can cause a worsening of their symptoms. You would know this if you have a really high, for instance, if you go out for a meal that contains many, like a lot of legumes or loads of starches, you're just not used to having it. Well, your gut's probably going to blow up a little bit.
Mhm.
Polyphenols don't do that. So they're really gentle. And when the bacteria chew them up, right, they're using them for energy and for their processes. When they break them down into smaller parts, those are the molecules that are quite well absorbed. So their availability, their absorption increases, and then they can travel in the blood and interact with your body's cells. And those metabolites are, reasonable NRF2 activators. But again, they're no way near as good as sulforaphane. Sulforaphane is thought to be by far and away the most powerful natural activator of NRF2, which is why we use it as a tool.
Mm-hmm. I
Yeah,
think
I think,
when I was talking to the practitioner at 3X4, she mentioned broccoli, of course, and I think she said I would have to eat about 10 pounds a day to get the amount that I would get from, or some crazy amount.
yeah,
Yeah.
it's a lot. And I mean, no one will eat that much unless you're a real fan, I suppose. Yeah, so the precursor of sulforaphane is the amount that is available to convert into sulforaphane is fixed at the seed stage. So it never becomes more than what is present in the seed.
Mm-hmm.
So obviously when a seed grows into a plant, the organism increases in weight, and it's that increase in weight, basically the concentration of glucoraphanin decreases whenever the plant increases in weight. So the best source is the broccoli sprout, because it's the smallest plant. It does need to be sprouted though, because otherwise there's no myrosinase, which is the enzyme that catalyzes the conversion of the precursor into sulforaphane. And in the plant, as in many other plants, those bioactive molecules are part of the plant's defense system, which discourages other things from eating it. And that can happen if you have too much sulforaphane and you have quite a dysbiotic gut. What we think what's happening is that when you activate NRF2 in the epithelial cells in the gut, you will stimulate a natural process where the body releases antimicrobial peptides into the gut lumen as one way of managing the microbiome or modulating the microbiome. So the body's got many ways of managing your individual microbiome, Rob, and that's just one of them. So if you're really dysbiotic, some people can experience a die-off of those pathogenic bacteria. So in some people, you need to be careful about how you go about consuming sulforaphane. It really only affects, the most dysbiotic people. But lots of clinicians deal with dysbiotic people. You just need to titrate it in slowly and observe what's happening.
Okay, that makes sense. Talk a little bit more about the signaling molecules as it relates to this. I think that's really interesting.
I don't know how many phytochemicals there are, Rob, but you just say there's 70 nutrients. I mean, something like that, high 60s, whatever it is. That's not many. There are many thousands of phytochemicals. So if you think of an orange, it's not just vitamin C and a few flavonoids, which are polyphenols. There's thousands of different individual molecules, different shaped, different size molecules in that orange. And so I guess theoretically, they all have the potential to be signaling molecules, but signaling molecules, I suppose, are what we would call a select bunch of phytochemicals, which have, I suppose, a marked effect upon nutrigenomic pathways. So sulforaphane is one. Indeed, some of the polyphenols, they're also nutrigenomic. There's a lot of them. And so essentially, you can imagine your genes are like a piano. When you eat a plant-rich diet, an unprocessed plant-rich diet full of phytochemicals, it's like they are playing a tune on your genetic keys, So if you have a diet, like I said, rich in phytochemicals, they're going to play a nice tune on your piano. If you have a diet composed of loads of fast food, they're going to play an awful tune on your piano, and therefore your cellular function will be compromised and your overall health will be compromised. Does that make sense?
Yeah, that makes sense. And it made me think about a lot of supplements out there are synthetic and it's very narrow with what you're getting. Whereas so you might take high dose of vitamin C. I think there was a study out a number of years ago looking at a high dose of vitamin C or someone eating a blood red orange that had much less vitamin
Oh,
C, but it
yeah.
had all these other components in there. Does that
Well,
play a
plus
little
it
bit into
tastes
what
good. I mean,
plus it tastes
vitamin
good?
C doesn't taste good. It's a white powder and it's acidic and it's kind of like, but that is the way a lot of people have done and still do approach nutrition. And so, I mean, you need a certain amount of nutrients, right? But they're not powerful nutrigenomically. By far and away, the best way to do this is with whole foods. And
Mhm,
my approach to nutrition is very, very simple. I feel like we should eat what we've been exposed to in the many, many years during our life on this planet.
mhm,
So, our genome, our cells have an absolute requirement for things in whole foods. We can't take things out of their natural food matrix and the food context and expect it to do the same thing as a food. And that's what the science seems to be showing. When you move away from whole foods to processed foods, you can't supplement your way out of it. You've got to have food. And so I like these concentrated food products as a way to get nutrients. For instance, like vitamin C, there's many alternatives to having a powdered vitamin C. It could be a concentrated food that's naturally rich
mhm,
in vitamin C. And there's many of those on the market today. So they give you not only the nutrient, but give you a good representation of what was in that food as it
mhm.
occurred in nature.
So you're getting all these cofactors and other things that were in the food that work with those, let's say, vitamin C or other nutrients and really make them more powerful.
Yeah, and look, one of the things about antioxidants, we used to think, and I'm going to refer to broadly to studies that have been conducted on athletes. Like you mentioned in my bio, I'm very interested in sports nutrition. I used to work in the fitness industry for some time, and now I cycle and do a few other things. But we used to think that when you provide antioxidants, it's going to reduce stress on the body, and therefore we will recover faster and be better athletes, and we can increase the training load and all that sort of stuff. Well, there's been a number of really well-constructed studies that have looked at the effect of antioxidant supplementation on athletic performance. Now, what they showed was that the athletes who were supplemented with these antioxidant products, and they were antioxidant nutrients, right? Vitamins A, C, E, those sort of things, beta carotene, they actually had less of a benefit that they derived from the exercise. The concept that I'm going to allude to here, I mentioned, is having a stressor and a response. So I don't know if you've done much sports physiology, but there is a specific adaptation to an imposed demand. So you put a stress on your musculoskeletal system, it will respond in a very specific way. And that stress manifests itself at a cellular level in terms of oxidative stress.
Mhm,
That redox balance is going to change towards being more oxidized. And so when you give an antioxidant, it actually gets in between the stressor and the response. It actually reduces the training effect.
interesting.
Okay, so it reduces the training effect. It's like instead of going at 20 miles an hour on your bike up a hill like you probably do, steep hill, Rob, I'm
Mhm,
giving you some props. So
thank you.
instead of doing 20, you might be doing 15. Your body has less of a stressor, and therefore the response is not as powerful, or as the magnitude of the response will be lower. So it's counterintuitive. I would have thought, and
Yeah,
we
I
used to
agree.
think antioxidants good for sports performance. And look, there might be instances where they do offer a benefit. Maybe when oxidative stress is so profound, that's the only way to get it.
Mhm,
And in some clinical conditions, that's true too. I mean, NAC is used, NAC, N-acetylcysteine. If you have, like, I think you call it acetaminophen or paracetamol poisoning,
mhm.
you take NAC, it boosts up intracellular glutathione really quickly and it helps you recover from that, reduces the toxicity. But those antioxidants seem to block your natural, response to stress. So they actually seem to block NRF2 as well, because they're reducing oxidative stress inside the cell,
Hmm.
which is the activating force for NRF2 activation.
Wow, so it's things aren't always as simple as you think they're gonna be. Yeah, I think right? I mean, as you
Well,
as you
I mean,
dig
the
into
body's
this
complex.
right.
The body's complex. And like I said, we have evolved in a phytonutrient rich environment, a very complex environment with so many different food molecules. the science of the last 100 years has kind of done us a bit of a disservice because we felt using a reductionist approach, we could bust food down into nutrients. This is what's important. And of course, they are important. You can't make them, but it's the phytochemicals that seem to have more of a profound effect upon the way the cell functions.
Yeah, it's a kind of applying that pharma model to nutrition. Makes sense on paper, but I think you're missing out on all these cofactors and other aspects of the food that you might be eating if it's a whole food source. And like you said, that's how we evolved as a species. Wasn't taking a bunch of pills. It was eating lots of plants.
Yeah, lots of plants and lots of animals and whatever we could get our hands on, I think. And, it's not just nourishing our cells directly, it's also nourishing the bacteria and fungi that live in the body. I mean, that's a massive part of nutrition and something that we're just starting to unravel at a very basic level now. How do we feed the microbiome and how do we feed it for different genotypes? Everyone probably needs a different diet, at least in many ways.
Yeah. So let's talk a little bit about how a practitioner might use nutrigenomics in their practice.
Okay. Well, number one, the pathway and transcription factor that we tend to focus on at Cell Logic is NRF2. In your particular instance, with more likely to develop oxidative stress, a practitioner would look at your report and go, right, what can I do to influence that oxidative stress? And of course, you would look at exercise, sleep, maybe intermittent fasting. These are all activators of NRF2, sunshine, and so on. But then we would look at what can we do with the diet? And how can we supplement with some powerful NRF2 activators in order to help reduce that oxidative stress? So that's one way as it relates to oxidative stress. Another way that we can influence the health of the body nutrigenomically is simply, and we're going to go back to basics here, simply providing prebiotic fiber to the microbiome. So when you feed those bacteria, they make, and it's a really nice relationship, it's a symbiotic relationship, they make short-chain fatty acids, including propionate or propionic acid, butyric acid or butyrate. And the butyrate is the primary fuel for cells lining the large intestine, the colonocytes. This actually influences gene expression. So when those cells, and it makes sense, when those cells are happy they've got food, the genes work better. And when those genes are expressed and the cell is working better, it improves tight junction integrity. So the tight junctions are those intelligent gateways, if you like, between epithelial cells. It's kind of profound because, and very basic at the same time. So when you feed your bacteria, they feed your cells get busy doing what they do, and their function is improved. But that can have really profound implications for someone with any sort of condition. I mean, if you have poor gut barrier function, autoimmunity is more likely, okay? Nutrient absorption is going to improve. Oxidative stress will certainly improve there. Your body's ability to manage its microbiome is going to get better. So your microbiome is going to be better. The gut barrier function is going to be better simply because you fed the bacteria in your gut. And so that's a nutrigenomic mechanism, the nutrients being the prebiotic fiber for the microbiome, and then those bugs giving our colonocytes the simple fuel that they need, which is butyric acid.
Wow, that's pretty complex stuff.
Well, yes and no. I mean, we know that we need fiber. I mean, the people, proponents of the carnivore diet will probably go, well, hang on, I don't think we need any plant foods. And look, I'm open to discussing that. It's a complex issue. Some people do extremely well on that. I mean, I'm not an epidemiologist, but, I kind of base my opinions on food a lot on how a food makes me feel. But it could be also that people experience benefits from that sort of diet simply because at the point in their life when they remove them, they happen to have a lot of dietary intolerances that may result simply from poor gut function. And when they improve that gut function through nutrigenomic means or otherwise, then they would probably have much better tolerance, and therefore their opinion about plant foods might be different at that point.
Makes
So I think a
sense,
lot
yeah.
of people go on the carnivore diet to lose weight, shape up, which is fantastic. It does work. But I also think that the colonocytes, they need food and they need butyrate. They might say, look, just eat some butter. Well, or some ghee. Well, I don't know about that.
Right.
I think we're meant to eat plant foods based upon the shape of our guts. I think we're meant to eat all foods that we come across, actually, of course, within reason.
Right. Interesting.
I kind of went off topic there, Rob. Sorry.
No, but this is great. I mean, this I enjoy this quite a bit, and I think our listeners will too. So you talked a little bit about sulforaphane it's not just another phytochemical. You want to just kind of expand on that a little bit?
Well, I mean, it's important, I think, when we approach nutrition and medicine that we, of course, think about things and initial, first principles and so on. But we've also got to follow the science, of course. I mean, we're all scientists, or should be. The science simply points to the fact that sulforaphane is the most potent natural activator of NRF2. So, I mean, we can look at phytochemicals as a pyramid, ones that don't, in terms of their nutrigenomic activity, they may do lots of other things in the body, but
Sure.
in terms of their nutrigenomic activity, there's clearly a pyramid. Some things are at the bottom, some things are at the top. And you can measure this. You can measure the effect of phytochemicals on NRF2 activity. You can do it in vitro, and I suppose you could do it in vivo as well. But yeah, sulforaphane just sits at the top of that tree in its ability to activate NRF2. So that's a pretty simple answer, I
Yeah,
guess.
that makes sense. That makes a lot of sense.
And look, these molecules like sulforaphane or whatever they are, resveratrol and other polyphenols from foods, these come from foods. Well, most of them do. Some come from foods that we've never eaten, that people just happen across and wow, that seems to have an effect. Let's make a product out of it. But I think these molecules that we use in our practice should ideally come, and importantly, should come from foods that have had a very long, safe history of human use.
Mhm.
So, and that's certainly the case with cruciferous vegetables. They are something that in the blue zone, parts of the world they eat a lot of, the Mediterranean, some parts of Asia and so on. Cruciferous vegetables not only taste good, but have a very long history of safe use. And if you look at the populations who have them, they're generally healthier with lower rates of disease.
Yeah. Makes sense for all
Now,
the reasons you mentioned.
and look, Rob, I'll just go back to oxidative stress. I made a note here, and this is something that people may not be aware of. Coenzyme Q10. There's two forms, the reduced form and the oxidized form. Ubiquinol is reduced and ubiquinone is oxidized. So it's something we make. So a lot of people may not know that we make CoQ10. It's just one of our secondary antioxidants. So not an enzyme, but a kind of a direct acting antioxidant. People supplement with it. And if you were to supplement with it, Rob, and you weren't, say, taking sulforaphane and activating NRF2, you would be in you would have an increased level of oxidative stress. Okay, that's what that genetic test identified, and we've talked about that a little bit. In that particular instance, that CoQ10 that you supplement with and that your body makes is likely to be burnt up, being used as an antioxidant quite quickly.
Mhm.
So for people who have high levels of oxidative stress and they're not activating NRF2, that supplemented CoQ10 is likely just to be oxidized quite quickly, okay? So that's a bit of a weird concept. You think,
Yeah, it
okay,
is,
it's an
'cause
antioxidant.
I take ubiquinol. It was recommended,
Yeah, I see that,
yeah,
and it's identified in your. And look, that's a good thing, but keep in mind that if your body is just trying to get on top of a big fire, so if you can think of oxidative stress in the cell as a fire,
Mhm.
that ubiquinol, without spraying water at the bottom of the fire, it's like you're just sprinkling it with a
I see.
a little spritzer. You're not really tackling the most important part of it.
Mhm.
That most important part of it is dealt with by those antioxidant enzymes like SOD,
Mhm.
glutathione peroxidase, and many more. In fact, there's one that's an NRF2 target called quinone reductase.
Mhm.
That's an NRF2 target gene, and it will reduce the CoQ10 back to its reduced form.
Mhm.
So in redox chemistry, the antioxidant is oxidized and the free radical is reduced, therefore neutralizing it.
Mhm.
So the important molecules in all this redox chemistry are the enzymes that recycle your body's own antioxidants like CoQ10 and
Mhm.
glutathione peroxidase oxidizes glutathione, so then it's reduced and it can then work again. Without the enzymes, glutathione and CoQ10, next to worthless.
Interesting. Since I am taking ubiquinol, I'm also taking sulforaphane. Is that a good combination, or is the ubiquinol kind of
Yeah.
a
Well,
a
Rob, we
waste?
don't know each other that well. I think I'd probably want to have a better idea of
Sure.
your whole life before I recommend specific things. But yeah, it's certainly probably going to have a benefit. But like I said, unless you're dealing with the basics, up regulating your antioxidant enzymes,
Mhm.
a lot of that CoQ10 will be burnt up.
I see. Okay. Well, that's good for me to know.
Just goes to show how you can personalize someone's nutritional treatment. So before you had that genetic test, you weren't aware of that. Okay. You
Right.
thought, okay, I'm pretty good, feel good on some days, not as good on others and my recovery is not as good as it used to be. Well, that happens, but it's actually given you a window into the functioning of your body, which is invaluable for practitioners, I think.
Yeah, absolutely. I mean, a lot of this came about, I did the 3x4 test about a year and a half ago, but I turned 60 this year, and I did some advanced lipid testing. My LP(a) was off the charts high, and some of my other markers weren't terrible, but they weren't exactly where I wanted them. So the last, 5 months, I've really been trying to focus on, a lot of different things, mostly to get that lipid profile back in line, because I guess we're finding out more and more about LP(a), how critical that can be to heart health. And, most everything else I'm fine with, but that's a concern of mine. So this has been part of what I've been doing the last 5 months or so.
Yeah, and I mean, you look at your levels and your family history and your genetic predispositions, and they say the genetics loads the gun and the environment triggers it. So I've had said to me many times, well, my dad had it, so it's kind of inevitable. Well, it depends on how you want to live your life. If you want to live it proactively and you want to make the most of what you've got, well, you're doing what you're doing.
Yeah.
So that's a glass half full sort of an approach, I think.
Yeah. So it'll be, we can talk about this offline, but it'll be interesting. I'm going to have the testing redone here in about a month and a half. So we'll see if all these things that I've been working on have made much of an impact, but I'm hoping that they will. Yeah.
Yeah, I hope so.
I guess, maybe another question here, and if there's anything else that you want to make sure we're touching on, but, how do SNPs influence the function of genes, by extension, metabolism? That was a question that...
Well, yeah, I think we've touched on that a fair bit. And essentially you've got, 20,000 genes. They can have SNPs on, which is just a mutation. You can be homozygous, heterozygous. And, the tests that you can take, and obviously there's various labs, not just 3x4, but many out there. I think 3x4 is excellent. The report is very easy to interpret, but it can impact your body in so many different ways. And so any report's going to highlight the most important things. And I think for a practitioner, it's about understanding the best ways of, dealing with that SNP that you might have. So it depends. We've focused a lot on oxidative stress, but there's also things that affect the mood and detoxification pathways that are, really important to address. So, I think the key is really looking at the report and producing a treatment plan that addresses those issues.
Yeah, makes sense.
Specifically.
Yeah. We've talked about a lot of different things here, and I know you've got an upcoming webinar with Dr. Supplement Store that's going to go deeper on some of this. You want to just share kind of where you're going to take this in that webinar, so they know what to expect if they want to go deeper on some of these topics and how to apply it in their practice.
Yeah, and I'm really happy to be doing that webinar for the US audience. And so in this podcast, Rob, we've talked about some specific things, but it's mainly been in theory, some broad theories and concepts. The webinar will delve into more theory, of course, but there'll be more of a practical focus. Okay, we'll look at some 3x4 test reports. We'll look at some case studies, which will highlight the impact of utilizing not just sulforaphane, but other nutrigenomic molecules and other treatments, really to enable practitioners to see that these things are worthwhile, see the potential benefit for their patients, and want to utilize them in their practice. So, I hope that people come onto the webinar. I think it's going to be very interesting, and I'll share a lot of insights for the viewers.
That's great. I'm sure it'll be awesome. And so we'll help promote that as well. So that'll be in the newsletter. We'll include a link from the podcast landing page to the webinar sign up, and we'll keep those two things connected even after the webinar's gone live and it's on demand. But, Matt, I want to thank you for coming on the show, and this was really interesting. I know the audience is going to find it fascinating, and we'll look forward to going a little bit deeper, figuring out how to take this information and apply it into their practice after your webinar. So thank you so much.
I thank you, Rob. It's been great chatting to you and getting to know you. And for those people who are thinking about coming onto the webinar, what have you got to lose? I think you'll get some really good information, and we'll look at some case studies and open up what I hope is going to be a whole new world of potential benefits for you and your practice.
That's great. Well, thanks again, Matt. Appreciate it.
Thank you, Rob.
Thanks for listening to the OneMedicine Podcast. I hope you found today's episode interesting and came away with a few insights you can apply to your practice. If you're looking for the show notes, they can be found in the link below. If you want to go deeper on this topic or anything else, please visit todayspractitioner.com and consider registering for our weekly newsletter as well. Thanks again, and I hope you'll join us next time.